if you have y equals inverse sine of x, what is an inverse trig function? If you solve this for x, it's equal to the sine of y. What is y? Drew, what is y? Because you missed it yesterday. It's just an angle. That's all it is. Okay, girls? If you realize that's what it is, then it's a lot easier. I think it's a lot easier. Okay, so when you get your domain and range, either we could go back to the original function, which is y equals the sine of x, and they're inverses of each other, and we can switch domain and range, or you can think through it. Okay, Jack, what's the domain here? If I have y equals inverse sine of x, x are the inputs, so what's true about the sine of y? It's going to be between what? Okay, so x is going to be between 1 and negative 1. I don't think you can ever hear too much about inverse trig, honestly. I think you guys have a tough time with it. I have to think a lot when I do these. I mean, I suppose you could memorize, but I'm not very good at that. So I'd rather think. I have too much stuff to know. Okay, then what will be our range? If you're looking for an angle, do you remember how we restricted that? Yes, y is going to be between pi over 2 and negative pi over 2. There's a bunch of angles you could get, because if I have more than one, then I'm not going to have a function. So we restrict that. So that our angle measures will always be between pi over 2 and minus pi over 2. And on your calculator, they always will as well. Because I want my function to always be increasing. Let's draw the sine function. Here's the sine function, and its inverse function would look like, see if I can do this. That's the inverse sine. Is that a function? No. Okay, let's see if I can do this. I'm not very good at this, but I'm going to try. So we want not to have we want our inverse to be a function. So if I restrict myself here on the original function, then I'm going to restrict myself right here. And this is going to be what? This is 1, this is pi over 2, and this is minus pi over 2. Whoa. That's why I don't like the chairs. No. I've already broken my arm once. I don't need to do it again. Okay. Now, what I do to restrict it, I want my function to always be increasing. We just have agreed to do that. That's all. We could have taken any place on our sine function. We could have been decreasing and said we're going to be between pi over 2 and 3 pi over 2. We could do that, but we've all agreed we'll take this interval. Okay? Your calculator will always give you that number. So if you really, truly are looking for a value someplace else, like over here, well, then you're going to have to figure it out and go to the correct quadrant. So that's sometimes what they did. When they first brought in the graphing calculators, that's what they did with the calculators. And I go, because that didn't test calculus at all. That tested whether or not you knew this, which I thought was ridiculous. They have since gotten rid of it. And those are really hard problems. When you have to get an angle where the angle answer is not in this restricted range. This is just a plain old inverse trig function. Depends on your context. So now, can I slide this? Oh, I can't. Good. And what I'm going to do here, take that and move it. What did I do before this technology? What about the cosine? Again, I'm going to have a problem. We're going to do the tangent. Okay, let's first graph the cosine function. And we're going to restrict this because if you It's inverse. It's not a function. Okay, this one's kind of weird looking. I want it to always be increasing or decreasing, so I'm going to restrict it. I'm going to try to be always decreasing. Darn it. It won't do that for me. But anyway, okay, so now I want the inverse. Oh, I always have a hard time with that. Somebody want to draw it? The inverse cosine. Because I always want this to be decreasing or always increasing. So I could have taken this interval. But we've chosen, so if I have y equal the cosine of x, we will restrict our angles to be between 0 and pi. What's our range for our original function then? Still negative 1 to 1, right? So when I do the inverse, what will be true about the inverse? So y equals inverse sine of x. My x's are going to be my range now, right? Between 1 and negative 1. And my angles will always give me answers between 0 and pi. I kind of know what it looks like. I'm just trying to think. So if I wanted to take this, I have 0 and 1. Let me do it in color. That's what I'll do. 0 and 1 is on my cosine. Then I have what? Pi over 2, and then I have what? 0. And then I have pi and negative 1. So on my inverse, I'm going to switch those. So it's going to start at 1, 0. Then it's going to be 0 pi over 2. Did I do that right? And at negative 1 and pi. So 1, 0. It's going to, now this is where? That's pi over 2, right? About, well, how big is that? It's 1.5, right? 1.57. So I'm going to go to 1, which is here, and that's 0. Then when x is 0, y is pi over 2. Well, this is just 1. Pi over 2 is up here. And, forgot my parentheses, when I get to negative 1, I'm up to pi. Again, this is negative pi over 2, so negative 1 is here, and I'm going to be up here. Whoops, almost went to the wrong one. So it doesn't, that's not a function, I got to be careful. Now, if I take y equals x, try to visualize this. Can you see this as the reflection over that? Kind of have to turn your head. I mean, I'm turning my head. So you're only looking at this blue piece. I'm kind of out of colors. This multicolored piece. It's this one, and then it's the green one. I just plotted some points because I'm not very good at this. And this is going to go up to pi. There. Okay. We restrict it because if I don't restrict it, my inverse trig is not a function. It's going to go forever. And then what is my calculator going to tell me? That's the problem. Okay, what about inverse tangent? Cosine is the only one that's kind of weird. When you get your answers, you're going to have answers from the first and second quadrant. Whereas both sine and tangent are going to be the first and the fourth quadrants. And tangent's going to exclude the pi over 2 because we have asymptotes there. Because it has to always be increasing or decreasing. So if I were to take, let me try and find another color. If I were to take this part of my graph and you invert it, you find the inverse, I'm not going to get a function, am I? Okay. And again, if I were to take from 0 to pi, I've got the same problem here. Sorry, I'm off a little bit. If I try to find the inverse of that, I'm not going to get a function. The definition, and you guys are able to do this, a 1-to-1 means for every input, because these are 1-to-1 functions, because if you're going to major in math, you're going to hear this. Not everybody's going to major in math, but you might take a lot of math. But for every input, there is exactly one output. You could end up taking enough math that you're going to hear this. I'm sure you will in college. And for every, how do you know about linear algebra? No. It does sound like it's easy, but I think it's one of the hardest classes. That was for me the hardest class. And for every output, there is exactly one input. Do you remember the horizontal line test? Do you remember that? The function has to pass the horizontal line test. So if I take this, the cosine here, and I go from minus pi over 2 to pi over 2, I'm not going to pass the horizontal line test. So the only way you're going to get a one-to-one function is it must always be increasing or always decreasing. So it's always increasing or always decreasing. So it's possible you'll take enough math where you run into this, depending on what you're going to do. And what I found with students is that they end up taking this, and then next freshmen they do Calc 3, they take linear algebra, and by now you are halfway done with a math major. And you don't have to take a lot more to get a math minor. And if you have a math minor and you're in biology, it makes you far more employable. You have a better chance to get a job. So you take as much math as you can stand. Linear algebra is the tough one because it's all theory. Well, first you do matrices. That's easy. They suck you in, and then they hit you with the proofs, with kernels, null sets. Yeah, my daughter would call me up, Mom, how do you prove this? I go, you're getting your PhD in math. I don't think I know anything compared to you. And I didn't. It's been too long. And then there's some other math classes. You can do topology, which is the mathematics of surfaces. So some of you have been trying to solve my little puzzle here. I think it's all tangled up again. This is a topology problem. It's all about surfaces. So you can take that kind of math. You can go into statistics. And then a full math major will end up doing proving all the calculus that we're doing now with epsilons and deltas and crazy things. And if you like doing that sort of thing, you major in math. If you like solving problems, you go into engineering or applied math. Yeah, well, I didn't know that. But I got through it. Yeah, I can, but now I got to undo what's there. It's all surfaces. Okay, and once you see it, it's really slick. Okay, let's do the inverse tangent now. All I'm doing is reviewing your inverse trig because I think inverse trig is not so easy. Am I right? Okay, let's draw the tangent function. Now we've got problems here. Where is that? Pi over 2 and minus pi over 2. Okay? Okay, Grant? I want to do the inverse. So I can draw this one. I'm better at this one. Now, Mrs. Hersman, you guys have some limits in here. She draws the inverse, and I'm sorry, that's a little bit off over here. Don't you realize that? Okay? The vertical asymptotes will now become what? Horizontal asymptotes. Okay, Trevor? Nick? They're horizontal asymptotes. And if you were to draw another cycle of this is pi over 2, this is minus pi over 2, then you would come up here, and do I have a function again? No, I don't have a function. It doesn't pass the vertical line test. So what are we going to restrict this one to be? No, so I have x equals I have y equals inverse tangent of x. I prefer to work with the original trig functions when I do the limits. It's so much easier to work with those. Pardon? No, because you have to restrict it. The range is going to be what? What's even the range going to be? The x's are going to be, you're right, I'm sorry, I misunderstood you. X is going to go from Negative infinity to positive infinity. But what are the y's going to be between? Right. Pi over 2 and negative pi over 2. And so when you put inverse tangent into your calculator, your answers will always be between negative 90 and positive 90. And if you want me to dig out one of those old problems from the 90s to show you how you could possibly get some other answer than what's on your calculator, I can do that. They are very hard. At least I thought they were hard. What is this? I was. These kids in there. Hey. Okay. Any problem with this? Is it? You remember your inverse trig a little bit better now? Now, if you get the Inspire calculator, the graphs are much nicer than on the 84. Much nicer. Easier to see. Okay. Simplify the following inverse trig functions. I am missing a parenthesis. So we are on the next page, you guys. Okay, Ori? I want, first off, I don't like that arc tangent or arc sine. So I change it because I just can't do it. It's odd, though, because when I went to high school, that's what we used. We used arc. But I don't like it. Now, remember, okay, guys, you should do this problem. Those who are doing nothing. John, put that away. Guys. David, time to wake up. What is this? You are immortalized forever. That's the angle, right? Okay, so let's go and do this. Nick, what'd you get for an answer? It says the sine of my angle is equal to 1/3. I had fun at the University of Minnesota with problems like this. Okay, Michael, put your phone away. Because the professor, who's brilliant, he gets out his calculator. He said, what are you doing? Well, he said, I can't do that. I said, you're right, you can't do that, but why can't you do this? If the sine of my angle, here's theta, is 1/3, then this is 1, and this is 3. That's the only thing probably I knew more than he did. And then what's this going to be? Square root of 8. And 2 radical 2 is fine. The only reason we ever had to do 2 radical 2 was because of the slide rule. It's the only reason. There is no other reason. So why it's on the ACT is beyond me. Radicals. Who cares? Who cares? So I don't know. The ACT should be changed. Because it's 1 squared plus something squared equals 3 squared. So to get this, you have to do the square root of 9 minus 1. Okay. Well, now what's the tangent of that angle? 1 over the square root of 8. That's a fine answer. There's nothing wrong with that. Well, you could rationalize it, but why? No, I haven't. Your previous teachers have. No, before. I'm only a calc teacher. This is my angle. So this means this. The sine of my angle has a ratio of 1 to 3. Once you know 2 sides of a right triangle, you now know the third. Right, Ori? Right? Okay, I'm making sure you understand it. That's it. Shall we do the next one? I don't care. You know what? I have no idea how big that is. Oh, yeah, I actually do. Square root of 8 is pretty close to what? Square root of 9. Okay, now we're going to think. How does the square root of 8 compare to the square root of 9? It's a little bit less. So when I divide by a little bit smaller number, so this is approximately 1/3. Is it bigger than 1/3 or smaller than 1/3? I'm going to divide by a little bit smaller number, so it becomes bigger. I'd rather have you know how to do that, so that when you plug it into your calculator, you get the right answer. Okay? Okay? That has much more meaning than knowing what to do with the square root of 8. That's a mechanical thing. Big deal. Okay, what about this? Oh. Okay. Guys. Ori. What's this one? Yeah. Yeah, what is it? We can simplify that. You'll have x's in your answer, though. What do you mean x over 1? Okay? I can't do this in my head. Sine of theta is x over 1. So now I'm going to do what? Draw a triangle. Hopefully you're ahead of me. Do you have your triangle drawn? Good. Oh, he is way ahead of me. So this is x, right? This is 1. Why am I doing this? Because we had to do some of this yesterday. 1 minus x squared, right? So what's the cosine? Yeah. I don't know, for some reason my professor knows how to do that, but he didn't transfer it to the numbers. Because you have to do this to get the derivative of your inverse functions. We did those yesterday. And I will present those without proof unless you want me to go through them again. Is that okay? Ask. Ask. Question? Good. And you know, I know it's the third time you've seen some of this, but yeah. Well, you might actually master it. Okay, John? Get this one? See if I can do it in my head. What's the answer, Grant? What'd you get? Yeah. One over the square root of 1 plus x squared? Do I need to do it? Okay, so this is theta. Okay, the tangent of theta is, Grant, what's the tangent of theta? No, it's x over 1. That's what that says. See how I don't even think of in terms of inverses, because I don't know. Okay, here's my theta, and I could actually extend it a little bit further and talk about restrictions, but I won't. Okay, Grant, what's the other side?
1 squared plus x squared versus square root of 1 plus x.
Okay, and I want the cosine. So it's 1 over. There you go. And we used it yesterday. Matt, put the Rubik's Cube down, please. You guys, you can do it. I can't help you solve the Rubik's Cube. I have no idea how to do it. But anyway. Okay, now we have a little problem here. These problems you have not done before. This is a BC topic. Okay, Sam, put that away. Here's what I do. You can just use the graph of the inverse tangent if you'd like, or you can say, I'm going to take the limit as x approaches 2 from the right, and then I'm going to write it this way. The tangent of my angle is equal to 1 over x minus 2. Now I'm coming in from the right. So when I substitute in 2 from the right, the tangent of my angle is going to be getting closer to 1 divided by a positive number or a negative number. Positive 0 from the right. Okay, so that's going to give me positive infinity or negative infinity? Positive infinity. Okay, Grant. Except these guys up here are kind of bugging me. Because if you put in 2 from the right, it's just a translation, but forget that right now. Okay, Grant? I'm going to take this limit. I'm going to go ahead and put 2 in. I don't know how to write it correctly mathematically, so I'm going to put 2 right in there, because that's what we always do. And so I get 1, and 2, a little bit more than 2 minus 2 is going to give you 0, but it's going to be positive. So if you have 2.001 minus 2, that's a positive number. As x approaches 2, for this equation, theta, the tangent of what angle is going to go to positive infinity?
Yeah, it's going to go to
So I'm going to draw my picture.
tangent of pi over 2.
What's the limiting value? It's pi over 2. What happens if it were negative infinity?
Negative.
Be negative pi over 2. So you don't have to do it that way. You could graph that if you want. So it's going to be what? Pi over 2. Because the inverse tangent looks like this. And this is, when I put in 2 in here, That's going to be 1 divided by 0. So I find that really hard to think about. So I rewrite it like this. So it's basically, when I put in 2 divided by, maybe it's easier this way. Let me do it this way. It's the inverse tangent of 1 divided by 2.1 minus 2, which is positive infinity. I need you guys to be quiet. If you're not interested, that's fine. So if my x is going to go to my positive 2, my function is going to positive infinity, what's the limiting value of that function? Pi over 2. So it doesn't matter which way you think about it. This is the inverse tangent function. No, it is the inverse right here. So I want, when x becomes 2, my inverse tangent of infinity. I don't understand it very well that way unless I look at this. I want to find the inverse tangent of infinity. X is not x is infinity, but 1 over x minus 2 is infinity. Make it 1 over x minus 2. There we go. Those are going to be hard for you. Oh, this is easy. Do you want me to do this again, or are you okay with just saying what it is? Okay, so y equals inverse sine of x. Why did they do the implicit differentiation yesterday? Because I don't know what this is. If I don't know what it is, I can solve for x. And so x equals what? Sine of y. I will take the derivative implicitly because I know what the derivative of x is, and I know what the derivative of the sine of y is. So, Lizzie, what do I get?
The answer is 1 over.
Well, I know I want to do this, though. What's the derivative of the sine of y? Cosine of y times the derivative of the inside function. Okay. And so it's times dy dx. So if you solve for dy dx, it's equal to 1 over the cosine of y. Well, I don't want that. I want x's in my answer. So do you remember how to do that? Now you could go ahead and put cosine of inverse sine of x there. Sorry. You could put inverse, you could do this. I don't want to do this. I mean, you could do that, or you could just say, well, y is equal to the inverse sine of x means that x is equal to the sine of y. Then I'm going to draw my triangle. Okay, Eric? You are. But what are you going to do if you don't remember on the exam? Here's my angle. This is what I just did. X. This is 1 square root of.
1 plus x squared.
Sam?
With x squared minus 1.
No. Because you're going to end up probably with a numerical answer. So if x is equal to a half, you'd have to put in a half. And then you'd have to figure it out again. No, because it'll be multiple choice. It'll be multiple choice. We have a homework quiz tomorrow. Okay, and it's hard. Well, it's ready. Tell me if you want to take it today. Okay, are we ready to take the cosine of this? What's the cosine of this? Oh, I did that right? Oh, it's 1 over the cosine. It's 1 over this. You guys, do I have to move you? You're the only ones chit-chatting. Actually, you are. I know, but that means you still need to be quiet because people did ask for it. Okay. And we'll get to some with some chain rule in it. Okay, what about this one? Remember, all the cofunctions are negative. So that's an easy way to remember this. And now, so there's 2 answers if you try to integrate this. Okay, the derivative of inverse cosine, I'll write it out, equals that. The derivative of inverse sine is equal to positive. Remember, but all the cofunctions are negative. Now, if you integrate this, you're going to get you get 2 different answers, but they're going to be equivalent. Don't worry about it. What about the derivative of inverse tangent? You guys can do this yourself if you want. The derivative of inverse tangent, this is the one you see the most often. Okay, Eric, do you know that one? Okay, ready for the chain rule? And now you actually can fill out that orange sheet that I gave you. I got to run some more. Oh, how are we going to do this? Chain rule? No. What rule is this? Quotient. So you should be doing it with me. Okay. It's the denominator. I don't like that word, arctangent. Times the derivative of the numerator. 0. It's below the derivative of the upper one, d high, minus high in the derivative of our tangent, which is 1 over 1 plus x squared over the denominator squared. And no, I can't make that negative 2. So that's what it is. And you could simplify it slightly. It's negative. Now, if this is in the denominator here, it's going to be in the denominator of the big fraction as well. You should verify that for yourself, that you believe that, instead of believing everything I tell you. That's the best you can do. I'll take any form. I'm not picky. How do I get that? If I multiply the numerator by 1 plus x squared, that will go away, and then I multiply the denominator by 1 plus x squared. See how that works? Because this is 0. So I put the negative in front. I could keep it in the numerator. Doesn't matter. Okay? What's our next one? Oh, we only have one more. You guys want to try this one? Maybe Eric will come up and do it.
Yep.
What rule do you have to use here? I have to do the chain rule, and I have to use the product rule. I would like to give you a chance to do it. Okay, John, you want to come up and do this? Make sure you know how to do it. Somebody said they want to come up and write it. Got to write it nice, though. Bjorn, do you know how to do this? You want to come up and do it? I would have you do it on my iPad, but it doesn't write that well. Yeah. I think Bjorn said he'd do it. Sam's going to do it? Yeah, of course. Yeah, you got a few things here. Oh. You did the easy part first. That's what I do. Plus. You can slide the board so you don't have to do that. See, I'm just short. There you go. Plus x
Wait, that's a predicament. Square root of x.
times the derivative of that thing.
1 over x. So then I have to cancel it. 1 over x plus 1. 1 plus x, sorry.
Well, it's 1 plus the function.
No, but see, but you're doing the square.
Oh, yeah. Right.
Well,
1 over.
no.
You don't have over.
No, no, 1 over yeah, 1 over x plus 1.
Yep, 1 over 1 plus x squared.
Well, no, but
1 over 1 plus input squared.
which is x squared, is the square root of x. So
1 over 1 plus
x
the square root of x.
squared, which is x
That's right.
squared.
There you go. He wanted to see that. Some of you need to see that. That's okay. Times The derivative of the square root of x.
A really large one is throwing me off.
The what is throwing you on?
A really large one.
And you've done that one so many times you kind of learned it. That's it. I mean, you can make it nicer looking, but who cares? You know what? If you had to do something like that in physics, then you'd put it in your calculator and you'd just evaluate it. Actually, I would use n derived. Okay. I think that's it on this one. It is. So I really strongly recommend you do these problems because they're not. I don't give you the easy ones. I only give you the hard ones. What fun would that be? Now we're going to get out the green one, and is the inverse trig on here? Oh, or let's summarize this because you have that orange sheet. So if we know this, then this is equal to what? 1 over square root of 1 minus x squared. Then what is the derivative of inverse sine of f of x? This is on that orange sheet you have. Yeah, I gave you the ones with all the derivatives, and there are only so many you can anti-differentiate. So it's 1 over the square root of, what's my input? F of x squared times f prime of x. That's what you did, more or less. You did with tangent. So if I have the derivative with respect to x, okay, so cosine is going to have a negative. Do I have to do the cosine? Inverse cosine. What if I do inverse tangent? What's that one look like? That's the one you did. 1 over 1 plus x squared. So what's the derivative of inverse tangent of f of x? It's 1 over 1 plus, what's my x now? What are you going to put in here? F of x squared times the derivative of the inside function, which is f prime of x.
Right, now that I'm
Yeah, you've got that on that orange sheet, and we're almost done filling it out, actually. We have to do the logs. Oh. Oh, how are we going to do this? Well, we're going to go right to the end. Okay, we ready? Well, we had a few interruptions. Okay, where is this little guy? You should be able to do this one now. These are the log functions. Do you guys remember the derivative of the natural log? 1 over x. Why? Because I have y equals the log of x. So if I solve for x in terms of y, x equals what? E to the y. Now let's take the derivative. Well, I don't know the log of x. I mean, let's say I forget. I mean, I've learned it, but this is what? 1. Because it's kind of cool to see why why it is 1 over x. What's the derivative of this? It's e to the what? Y times the derivative of y. So dy dx, which now reviews some properties of logs, it's 1 over e to the y. Well, what's e to the y? Why? Because e to the y is equal to e to the log of x. Those are inverse functions. You remember e to the log of x? This is just x. Remember that?
Yep.
So this is equal to 1 over x. Nope, it's just 1 over x. Now, what do you do if you have a different base? Matt, you remember how to do that? Now, with the new operating system on the calculator, I don't need to know change of base for calculations. However, I am going to have to do change of base here. So y equals natural log of x divided by the natural log of a. Do you remember the change of base? Now remember, the natural log of a is just a number. It's a constant. So what's y prime? We're going to ignore the constant. No, it's easier than that. We're going to pull this constant out, because what's the derivative of the constant? 0. And then you do times the derivative of the natural log, which is 1 over x. I never memorize this one. I always do it this way. I never memorize it. You can if you want. There's so many things you have to memorize, and we haven't gotten to them yet. Okay, so can you fill this little table out? Yeah, well, you got time. Try and fill it out. Do you want to come up here, Ori, and write it down? I didn't think so. So do that. We're not going to do logarithmic differentiation. If you see it in the assignment, throw it out. It's not on the exam. We don't need it. If you get to part B there, we're not going to do it. Okay? Are you guys going to tell me what to fill in here, or do you have it?
I got it.
Okay. Ready?
1 over f of x times f prime.
Yeah, don't forget the f primes. These two, these other bases, they're the tougher ones. Because this is no. Derivative, this is a to the f of x times the natural log of a times f prime of x. So what's this one? The log base a. So it's 1 over f of x times 1 over the log of a. If my base is e, then this is just 1, so it works, times f prime of x. That's why I was worried about this. This is 1 over f of x times f prime of x. E to the f of x is e to the f of x times f prime of x. Do you know the derivative of the absolute value function? You don't have to know it on the exam, but it's on one of my examples here. Do you guys remember what that is? Yes, I could do that, or it's the absolute value of x over x. I'll leave it to you to prove it, because the absolute value of x is equal to the square root of x squared. Now, I know you don't think of it that way, but let's read it backwards. What is the square root of x squared? The absolute value of x. I don't read it left to right, I read it right to left. So when you want to take the derivative of the absolute value, take the derivative of that composite function. And by the way, another form of this is this. You may run into it. You should definitely not run into it on the exam. So it's not on my list to memorize. Notice it's not on that sheet. But it's just kind of nice. So I'm going to leave you to do a few problems. And we're going to skip this. Now if okay. So what is that? Well, we're not done. Let's get this done. It's not time to go. Is it? It's 12:02. We got 5 minutes. But this is fast. This is fast. What is this? It's 1 over what? Cosine of theta times what? Negative sine of theta. You can make it negative tangent. Who cares? How about this next one? Okay, so it's 1 over the natural log of your base times 1 over the function, right? Times the derivative of the function. 2x. What about this one? Yes. But you can't do anything with it. Who cares? Now, remember the derivative of absolute value is the absolute value of x over x. So this is going to be the absolute value, it's going to be 1 over that. 1 over the absolute value of x cubed minus x squared. Now, I got to multiply it by the derivative of the absolute value. So it's the absolute value of x cubed minus x squared over x cubed minus x squared. That's the absolute value of x, that's x, times the derivative of the inside function, which is 3x squared minus 2x. I don't know if there's any in the homework that have absent value. Probably not. Yeah, could I cancel those? Absolutely. Sorry for the pun. You could reduce this too by factoring x's, but I don't really care. If I wanted to evaluate that, maybe then I want to simplify it. We're not doing logarithmic differentiation. We didn't do it last year. We're not doing it this year. You didn't need it. It's not on the exam. They've taken it off. Okay, tomorrow you have a hard homework quiz. You better look it over. And it's long. Yes.